Welcome, everybody. My name is Paul Gannett, and I'm going to be hosting today's webinar. I'm Environmental Product Line Manager for Onset's line of HOBO data loggers. And today I'm going to be talking about measuring flows and water levels with web-based systems. And yeah, let me start right on in. There I am. All right. This is for those who aren't hearing me. If you're not able to hear, for those that aren't able to hear me, there's a couple of things to check. But let me go on because I assume most of you can. All right. Oops, sorry. Got to get my cursor back on the screen. First note is I want to let you know you can ask questions at any time. There's this questions panel over in your control panel. So just feel free to type in any questions you have. If I feel like it's going to fit in where we are at the time, I'll try to address it at the time. Other questions I'll get to at the end. I've allowed some time for questions at the end. I'm expecting to go about 60 minutes. It's a pretty packed full presentation that I have here for you. So I'm probably going to go about 45 minutes during the presentation, and I'm hoping to allow about 15 minutes for questions at the end. This webinar is being recorded, and we will make it available to all of you afterwards. And I'm going to start out with a poll as we are going through this very different time. I'm just curious to see how many of you are like me, working at home. Onset has basically all the employees that can be working at home are working at home. So I'm broadcasting live from my wife's sewing room. So let's see. So here's, let's see, you should be seeing a screen now. Yep. That allows you to enter in your situation, whether you're working at home, whether it's your usual place to be working, or if you're working in the office, and some of you that are fortunate enough to be working from a vacation home. Let's see. Oh, interesting. Pretty clear trend here. So I'll give you a couple more, another 5 seconds to get your final responses in, because it seems pretty clear. Let's see. So I'm going to close this out and share the results with you. And as you can see, 80% of you are shifted to working at home, just like me. Only 6% of you are working in the office, and another 11% normally work from home. So interesting. So over 90% of us are working from home. That's good. Keeping safe. Hopefully preventing the spread and containing things, and hopefully we'll get things under control and we'll come out of this shortly. So I should, hopefully you are seeing our presentation again. So let me continue on. Thanks for participating in that poll. And you should be seeing the agenda now. If you're not, let me know. Okay, looks good. And this is just kind of a rough outline of the sequence. I'm going to be going through things. First, I'm going to start out with why do we monitor flow? And probably most of you have a good reason for monitoring flow already. That's why you're attending today. So then we're going to talk about Weirs, Flumes, and Stage-Discharge curves as ways of determining flow based on water level, and talk a little bit about what might be the best options for your application. And then we'll talk about using our HOBO stations for web-based water level and flow monitoring. And as I promised before, we'll have some time for questions and answers. All right. So water flow covers a lot of different areas. Streams, rivers, storm sewers, irrigation channels, flood relief channels. So just got a few pictures here to kind of give you a good cross section. Let me say one thing that I'm not going to be covering today, and I saw a couple of questions related to monitoring flow in pipes, and the techniques that I'm going to be talking about today do not apply for pipes. So if any of you are attending hoping to learn about that, my feelings would not be hurt if you decided to do something else right now. But for the rest of you, hopefully what I have is going to be good for you. So why do we need to monitor flow? Again, I think you know better than I do, but here's just some of the key areas. We've got limited water resources, and we need to measure them, monitor them, understand what we're using. So monitoring flow is important for that. We're also trying to protect our aquatic ecosystems, and I saw, hopefully my audio is coming through. I heard one person said my voice is breaking up. Hopefully the rest of you are hearing me okay. I'll try to talk slower just in case. So I lost my train of thought here, sorry. Why do we need to monitor flow? Flood warning, obviously too much water is a problem too, so we need to manage floods and be prepared for those. And managing stormwater as we build up urban environments. We've got to deal with runoff from parking lots and buildings and manage it more effectively. All right. So just to put me in context, I'm going to ask you another question. So this is about what your environment is. And there's probably some areas that I haven't covered here. So my poll answers, I'm only allowed to have 5 answers. So if any of you are monitoring something other than these 5 choices that I've had up here, I'm going to ask you to enter those into the questions box in your control panel. So let me bring up this question. I'll launch this one. Questions are open. As I said, if you want to enter something else, enter that into the, we got some other good ones, wetlands and dam outlets. Yep, both good. Lagoons, yep, coastal. Coastal, you got to be a little careful of. We'll talk more about that. Creek, saltwater. Okay. I'll give you 5 more seconds. 1, 2, 3. All right, and then we'll close it out. Now we got a pretty good distribution here. Let's see. Let me share the results with you. Streams is the biggest category. So yeah, we will definitely be covering a lot about stream monitoring. Rivers are second, then coming down to stormwater runoff and storm sewers, kind of related, and irrigation. So we got a good mix of attendees, so that's great. So hopefully we'll have something for all of you. I'm just looking at the other fill-in responses to see if there's any no real outrageous ones. So all pretty, yeah, hydroelectric releases, that's another good one. All right, so let's continue on. So let me just kind of, some of this is going to be a review, probably for a lot of you. This is a review, is how do weirs and flumes work? And basically weirs and flumes are some sort of restriction in the flow of the water that causes the water to back up. And as the water backs up, that increases the water level. We often call that to increase the head behind the barrier. And the height of that head is a function of the flow rate. And there's defined formulas for weirs and flumes that can convert that water level increase into water flow. So it gives you a pretty accurate way of determining what the flow is based on the water level. And one footnote here, especially you guys that are in estuaries. These methods, at least the ones that I'm talking about, only work for flow that's in one direction, because it's measuring the head on the upstream side of the weir. So if you're in a tidal area where the flow is going both ways, these flow techniques will not work. So one question I often hear is, why don't we just measure flow with a flow meter? And this is kind of a picture that helps you visualize why you can't do that. Is you look at a cross section of a stream here, and the fastest flow is in the middle and in the upper parts of the stream. And then as you get closer to the banks, your flow is naturally slower. So if you're just using a current meter or a flow meter, you're just getting a point measurement of what that flow is. So yeah, you couldn't have enough flow meters to really monitor all of that. Whereas a Weir or a Flume will give you a total flow measurement, which takes all that into account, basically tells you your total flow in cubic feet per second. And the other reason that flow meters won't work in some cases is the streams are just simply too small for a current meter, because current meters are pretty, pretty big. And if you've got a stream that's only a few inches deep, a current meter isn't going to be able to measure that. So first, I'm going to talk about Weirs, probably the simplest way of measuring flow, and we see these all around us. Basically, it's an obstruction, a barrier that goes across the stream or river, and it's got a sharp edge on it. And that sharp edge is important for preventing the water from adhering to the downstream edge. If the water adheres to the downstream edge, it won't provide as accurate a measurement of the flow. And also, it has to be not a submerged flow. In other words, as you can see in this picture here, the water has to be free flowing out of the weir in order to get a valid measurement. And there's different shapes, rectangular, and which are usually used for larger stream flows. For smaller and mid-sized stream flows, we commonly use V-notch or trapezoidal, also known as Cipolleti weirs. So these are the common ones. And there's also hybrids where you can take like a V-notch weir and combine it with a rectangular weir to kind of better adapt to different types. As a matter of fact, here's a combination weir that has a V-notch weir down here and then a rectangular weir up here. So to really characterize a flow like this, you need to have two parts of your equation, or your conversion. So weirs can be used for a wide range of applications. They're very, depending upon the size of the weir, you can measure streams, rivers, storm sewers, irrigation channels. This is down here is a weir being used to measure a large, river flow. You can even get bigger. A lot of times your bigger rivers, you don't want to have a weir in it because that gets in the way of boat traffic. As I mentioned, V-notch weirs are best for the low flows, and the rectangular weirs are better for the medium and large flows. You need to at least have 0.2 feet of head above the weir crest in order to get a valid measurement. So that does mean that for low flows, you may not be able to get an accurate measurement with a weir. There also has to be enough drop in your waterway, your stream or river to ensure good free flow conditions to have this drop, like you can see between the upstream side and the downstream side. The nice thing about weirs is they're fairly easy to install. You just need to put a wall or a plate across your stream or river, so it's not so complicated. And it's also fairly easy to place your stilling well. You just have to make sure that your stilling well is not in the area that's influenced by the water flow through the weir. So if you put it up here upstream, or a lot of times people will mount them on the weir face, but remove away from the flow. It's supposed to be 4 times the maximum head from the weir opening is the guideline. One thing about Weirs you got to keep in mind is in order to have them perform accurately, you got to make sure that you do keep up with the cleaning. If it gets a lot of sediment built up on the upstream side, that can affect the accuracy. So they do require a little bit of maintenance. You'll also see Weirs used in storm sewers. They are fairly work fairly well for that, and also stormwater runoff applications. Here's a pipe with a little weir built into the pipe and a water level logger there that measures the water level in the pipe during storm events. So you see weirs in all sorts of shapes and sizes. Switching now to flumes. Flume is a little different in that it's a restriction in the channel flow. It's not really a plate that's in the channel flow. And again, that restriction or that throat causes the water level to rise. There's different types of flumes for different applications. This, I think, is a Parshall flume here, which is great for stream applications. Yeah, here's the range of applications, pretty similar to the range of applications for weirs, streams, storm sewers, irrigation channels. They're a little trickier to use for rivers just because the shape of them is so critical to the performance of the flume that sometimes it's hard to make when it's large enough to handle the flow of a river. One of the big advantages of flumes is you can use them in very flat flowing streams with low head and low flows, because they can basically measure down to zero water levels and still have a flow going through them. They also have less disruption to stream activity. So if you've got fish in the stream, a lot of times they can still go through a flume, whereas they won't be able to jump a weir. Installation for flumes is a little bit more work. As you can see here, you've got to create a little bit of a wall, and you got to make sure it's level when you put it in the stream. This is an example of a prefab flume, which is a great way of measuring stream flows. Concrete flumes can also be constructed, but you got to be very careful with the geometry to make sure that it's meeting the required geometry so you can get accurate measurements. Another advantage of flumes is that for most flumes, they're more self-cleaning, just because there's constantly water flowing through them and there's no hard obstruction. They keep themselves clean better. Some types of flumes, like a ramp flume, there you got to be a little more careful about keeping them clean because they can collect sediment. One little note here I wanted to make sure you're aware of is if you're buying a prefab flume like this one here, make sure that it comes, if you're going to use it with a water level sensor, make sure it comes with a built-in stilling well. The positioning of that stilling well is critical for the flume conversion equations to work accurately. So buying it with that stilling well built in, as you can see here, is the best way to ensure it's in the correct location. So here's ramp flumes. They're also known as broad-crested weirs sometimes. It's kind of a hybrid between a weir and a flume. It's kind of like a weir with a broad barrier. And so this is kind of like a side view. This is a view of an actual stream. And they're better for medium-sized and larger streams or irrigation channels. Here's just some things to keep in mind. When you're choosing a weir or a flume, make sure that it's rated for the full range of possible stream flows that you can have, so that it's not overflowing. You know, like you can actually, this one, if this was just a V-notch weir, you could see it's actually starting to overflow. So its measurements are not going to be as accurate. And then yeah, you just got to be careful of that. I would recommend setting alarms on your monitoring system if your system has that capability for the minimum and maximum valid ranges for your water levels. so you can at least know when you're outside of a valid range for measuring flow. Now I'm going to switch gears to using stage-discharge rating curves. And these are used more for bigger streams and rivers where you don't want to have an obstruction in the boat traffic, or you can't have an obstruction in the flow of activity on the stream. These require a little bit more work to get established because you got to come up with the rating curve. We'll talk a little bit more about that later on, but they can be an effective way of monitoring flows as well. The key with them is you've got to, at different water levels, determine the flow through different segments of the stream. So it requires a series of measurements across the stream where you determine the average flow in that segment, and then you basically add up those segments to determine the total flow through that stream at that water level. And you do that at low water levels, medium, and high water levels to build up your rating curve. So here's just kind of a quick summary of what I've just gone through, is comparing Weirs, Flumes, and stage-discharge curves. First row is just kind of looking at the applications. Weirs and Flumes have similar applications, small to medium-sized streams, where stage-discharge curves tend to be used on streams and rivers. The Flumes have the least disruption to stream activity relative to Weirs, and stage-discharge curves, of course, don't affect the stream activity at all. In terms of the head, how much stream flow do you need to have? If you're going to use a Weir, you need a little bit more flow, a little bit more head to be able to use a Weir. For flat streams, you're better off with a Flume. And measurement range, Flumes can measure down to 0, or essentially down to 0, whereas if you've got very large flows, you're going to need to go to some sort of stage-discharge curve. Just talking about installation, this is just a kind of a summary of what I said in the previous slides. The other thing you got to consider when you're setting up a Weir or Flume or stage-discharge curve is the water level sensors. There's a lot of different types, actually. These are the three most common ones: pressure-based water level sensors, ultrasonic, and radar sensors. The ultrasonic and the radar sensors sit above the stream or the water flow through the Weir or the Flume, and measure the water level by measuring the distance to the water. The pressure-based ones are measuring the water level based on basically the pressure of the water above it. You can get probably the best accuracy with water pressure based sensors. Ultrasonic, because of air temperature effects, tend to not be quite as accurate, so they tend to be used more in enclosed spaces where you have more control. Oops, sorry about that. Not to worry, my battery really isn't going to run out on us. It's a false positive, as they say. I've got to have my computer serviced. The ultrasonic, are more subject to air temperature variations. Radar give you a little bit better accuracy, and overall, when you take into effect the air temperature effects, but they're also more expensive and they require more power. The advantage of water pressure based ones is they're low power, so they're more suitable for battery powered stations. When you're using a water level sensor based one, water pressure based one, you want to make sure to have a stilling well integrated into your plan. The ultrasonic and radar are better for wastewater applications or frozen water applications because they're above the water, so they're not affected by stuff in the water. Let's see, I'm just going to check. There's a couple questions have come through here. Let me see if I can answer any of them right now. Yeah, there's a couple more specific ones. So I'm going to, we'll probably follow up with you more specifically on those. So talking a little bit about what we have at Onset for measuring water level. All of these are pressure-based water level sensors. We have standalone water level loggers, which get submerged in the water. And they're great for kind of monitoring historical information. These typically one will be in the water, then you have another one in the air recording barometric pressure, and then our software does the magic of calculating the water level. And then you can export that data to a flow conversion program to get flow data. We have our Bluetooth series water level logger, which you can offload with a mobile device, and such as your iPhone or Android device. And these, you also have to export the data to convert it to flow. And you can see kind of increasing prices here. And then these are our web-enabled stations. And this is what I'm really focusing on today, because these allow you to do remote monitoring of water levels and flow. And these also include integrated flow conversion. So it just really simplifies your process of getting flow data from your water level data. The difference between these stations is basically price. The MicroRX station is a little more affordable in the under $700 price range. It's cellular, web-enabled. RX 3000 station gives you a little bit more flexibility, including Wi-Fi and Ethernet options, but at a little bit higher cost. So actually I have some more detailed information on each of these. So yeah, so this is the HOBO MicroRX station. This is a graph done with our HOBOlink remote monitoring software. And it's interesting, one of the cool things about this is it's providing real-time flow data. So if you look at the date down here, I just offloaded this data today. You can see we got a little peak this morning in our flow down in the Quashnet River. And so I didn't even have to leave the comfort of my home to get this data. So there's an advantage right there of web-enabled stations. And as I mentioned, we've got pre-programmed water flow formulas in our HOBOlink software for converting the water level data to flow. And I'll show you how to do that in a little bit. We've got alarm capabilities built into these stations. So if you need to know when there's certain critical events, current flows or water levels that are reached, you can trigger on those. They use a non-vented ceramic sensor that provides high reliability and low maintenance. The barometric compensation is built into the station here, so that it does the compensation for barometric pressure changes automatically. It also has inputs for up to 5 of our smart sensors. For example, a lot of times people also want to monitor rainfall at the same site. You can just plug in a rainfall sensor into the same station. It's got an integrated solar panel here, so that it basically runs indefinitely. We've got a range of cable lengths. They can be standard cables or custom cable lengths up to 400 meters. And for shallow applications, we've got sensors that have a 4-meter range, 9-meter range, 30-meter range, and 76-meter range. For most flow applications, I find that people are using the narrower range sensors. Now looking at the RX 3000, this is our bigger station that can be used for monitoring water levels and flows. It's got the added flexibility of cellular or Wi-Fi and Ethernet communications. It's got more smart sensor inputs, and it's got inputs for up to 2 water level sensors. And how the water level sensors are connected is it's a module that plugs into it, and you just take it over there, and this is kind of cool. It plugs in there. So there's one water level module. You can install up to 2 of these. And you can also install other modules that we offer. We have analog input modules. So for example, if you wanted to connect a radar sensor to the station, you could do that using the analog input, and just choose a radar water level sensor that is or has a 4 to 20 milliamp output. We also have a module for wireless sensors if you want to monitor other environmental parameters in the area or stream temperatures perhaps. We also have a relay control module. A couple of the people in the questions that were sent in advance were asking about being able to trigger auto samplers, and yes, you can use the relays in the RX3000 to trigger an auto sampler at the site. Oh, here's a question about what is the cost range of additional smart sensors? Our sensors range in price from temperature sensors, which are, let's see, in the they're in the just under $100 range for a smart temperature sensor. Rainfall sensors are in the, let's see, are in the $200 range. Temp RH sensors are in the under $200 range. So wind sensors, again, can cover a wide range. So it just gives you a sense. We've got quite a selection of weather sensors you can choose from. So I'm just reading through another question here. That's why I'm pausing. Oh, somebody was asking, are our MicroRX stations backwards compatible with our prior HOBO water level loggers? They're not compatible. The MicroRX station is not compatible with our U20 series water level loggers. They are compatible with the water level sensors from our MX2001 logger. So if you want to convert an MX2001 logger, which has the Bluetooth mobile offload, you say, well, geez, now I want to use that sensor with a web-enabled station. You can do that. You can take the sensor, but you will need a new cable, and of course, you'll need the MicroRX station to do that. So, and here's the cable. You see, it's got a. This is the connector that plugs into the station up here, and this is the part that connects into the water level sensor down below. And as I just mentioned, these are the same sensors that we used with our MX2001 loggers. So configuring a station in HOBOlink, this is our software. So I've kind of shifted gears now. So there's going to be a series of screen capture to show you our software. And if you plug in one of those water level modules into the RX3000, or you have our MicroRX station, which has the built-in water level, you get these measurements kind of, automatically: barometric pressure, water pressure, differential pressure, and the water temperature. So those parameters, you just see them. Water level and water flow, you have to configure those. So here's how you configure the water level measurement. You can label it, of course. You have to enter in a reference water level into this. So this is a reference water level measurement that you took at a particular time in your stream, and you have to enter the time that you took that, and then just enter that once into the HOBOlink software, and then it uses that as your reference point going forward. Let's see. Oh, I just saw another question here. I'm going to switch over. I like breaking it up with a few questions. Somebody was just asking if Onset sells prefab flumes, and we do not sell prefab flumes ourselves. Some of our distributors do. So you might check out our distributors for example, in the US, I know Intermountain Environmental is one of our distributors, and they sell prefab flumes. So coming back to our software, to configure the water flow, you come down here so that the water flow selection is highlighted. And then let's see what happens if I do this. Yeah, you got to select your method. So we support 3 types of Weirs, rectangular, trapezoidal, and simple lighting, which are really those are the same, as well as V-notch Weirs. So you select that here, and then depending upon what type of Weir you select, you get different options here. So in the case of a V-notch Weir, you enter the angle of the Weir, so 90 degrees is a pretty common one, so you enter that in. And then you enter in kind of an offset for where you're measuring your water level from. If you're measuring your water level relative to the bottom of your V in your V-notch Weir, you just enter a 0 as the water level at the vertex, and then all your water levels will directly be H, or your head, and the formulas will treat those accordingly. So that's how you'd enter in for V-notch Weir. It would be similar for a rectangular Weir or a trapezoidal Weir. So I'm going to switch over to our questions just to see if there's any that relate to this. Yeah, there's a question here: do all HOBO loggers need to be used in conjunction with a flume or a Weir? And I'm assuming that's in regards to measuring flow. Yeah, you need to have either a flume or a Weir or a rating curve, and I'll talk about that in a couple slides. Oh, and that's the next question I see here. So perfect, we're leading right into that. So if you've got a flume, this is the choice you have. You select general flume, and there's all sorts of different types of flumes. We've talked about those before: the Parshall, the Palmer bullous, and broad-crested. There's different types of flumes. All of the flumes basically have equations that are in this form. So you have to kind of look up the coefficients and the exponents for the flume you have. And I'll show you a little bit more, an example of that on the next slide. But most flumes will have an equation in this form, which is the water flow is equal to a constant times the water level minus a head offset if necessary, raised to a head exponent. We call that N. And so those would be entered in here for the particular flume that you have. So let's go to the next slide and just look at a particular flume. So this is a prefab Parshall flume, and you can see it's got the water level markings here at the appropriate place, on the flume where the water level needs to be measured. And it has an equation that's in that form that I just showed you. Flow is equal to a constant times the head raised to N, the exponent. So you just look up the table for that flume, and in this case, in metric, your constant is 0.141. You'd enter that in here to the flume coefficient, and N is 1.55. So you'd enter that in as the head exponent. So that's all you need to do. And that is, again, assuming head offset of 0, which is assuming that you're measuring your water levels from the bottom surface of the flume. So, which is the most common case for a Parshall flume. So just some typical flumes that fit into this format: Parshall, cutthroat, Palmer bullous, and any other flume that can be expressed in this format. And broad-crested flumes, or broad-crested Weirs, I'm sorry, and ramp flumes fit into that as well. And in that case, you might need to enter in a head offset. So if you're measuring water level at this point in the water flow, this is a side view of the flume, and your head is here, you're going to have to enter in what the height of the head is. So you enter that in as your head offset here. That's your P. So again, pretty simple to do. Oh, and I want to just talk briefly about the case. Sometimes ramp flumes will have an equation like this where it's water flow is equal to a constant times L. Well, L being the width of the flume. So in that case, what you have to do is you multiply the constant times L, the width of the flume, and then you enter that in as your flume coefficient. So not that hard, but something to be aware of. So be careful when you're looking at the flume to see that the format of the flume equation is in the right format. There's also flumes in situations where you need to measure water level at 2 points in the flume, especially if it's a submerged flume where the downstream side is submerged. In that case, you need to do 2 and sometimes even 3 water level measurements, and our software doesn't currently support those types of equations. So switching gears to stage-discharge scenarios. So here's an actual stream here on Cape Cod where we're located. It's actually also a USGS site, which was handy because they have done the work of coming up with a stage-discharge curve and entered in, let's see, I think I highlight this. They've entered in stream flow and corresponding gauge height measurements at several different gauge heights over time, and they've built this up over time. And this, as I mentioned before, is using this technique of measuring the flow at several points across the stream to come up with a total stream flow and entering that as your stream flow here. And so it's tedious, but you know, once you've got it, you've got it, and you can build it up over time and increase the accuracy of that curve. So that's the stage discharge curve. Now, how do you enter that into HOBOlink? First, you have to have your field data. You've entered that into, you know, perhaps a rating curve generation program, such as the USGS Water Watch program, and they have calculators for that. And then you take points off of that curve that there's whatever software you're using generates, and you enter in the gauge heights and the discharge at several points. You can enter, I think, in up to 20 combinations of water levels and water flows into HOBOlink. So that basically maps out that stage discharge curve into HOBOlink, and then HOBOlink will do a linear interpolation between those points to calculate flow rates for water levels that are between those points. Hopefully that makes sense. So, as I mentioned, in some cases it's good to set up alarms. One of the cases where you may want to use alarms is to notify you when to take samples. And you can actually use the alarms in HOBOlink. You can set up the alarms to trigger your sampler, your auto sampler. So and trigger that relay that's in the RX3000 if you're using that combination. So that's another way that alarms can be used. And we also have the capability to kind of generate what we call system level alarms, because you want to, especially if it's a mission critical sort of application, you want to know if your system's down. So if it's missing connections or the battery's low, you want to set up these system alarms so you'd be notified in the event that those conditions happen. I'm just looking at the questions again to see if there's any I should touch on now. Let's see, can our hardware be used to measure flood irrigation inputs and runoffs. Oh yeah, yeah. If you are measuring flood irrigation, the you know, you can put a weir at the end of the flood irrigation, or at the input of the flood irrigation, as a way of measuring the water coming into that. That's I think pretty common to do. The other thing I wanted to say is that HOBOlink is compatible with some popular water management platforms like Aquarius and DataWise. We actually are just announcing our Aquarius data feeds is what we call our transfer of data from HOBOlink into these other programs. We're just introducing the Aquarius data feed right now. So I know probably several of you are using that. So that actually gets me through the slides. Okay, I'm not too far off of schedule, so not too bad. We're about 47 minutes into this, so I've got some time for questions. So I'm going to switch over to my question screen, and I got it coming in too fast for me. I'm going to enlarge it somewhat. So let's see. Somebody was asking for pricing. For ballpark pricing for a station with a sensor and a data plan, you're going to be around $1,200 or so, US dollars. For a specific quote. Sorry about that. We can follow up and get you a quote for exactly what you need for your application. Yeah, here's a question about tidal environments. Yeah, they're tricky. We do have people that are monitoring streams that are coming into tidal environments. So if you're in the stream where it's mostly flowing down into the tidal area, you can use a Weir or a flume in that environment, and you just have to be careful that your water levels are actually measuring the stream as opposed to tides. So I just use a note of caution if you're trying to measure a tidal area. There's a question about the types of cellular service that our systems are compatible with. We use 4G cellular, but it will fall back to 3G and 2G if there isn't 4G available. So it'll keep searching until it finds the available cellular coverage. So make sure you've got enough signal strength. Go out there with your cell phone or something and see what kind of coverage you have before investing in a system. Sometimes you can put in a Wi-Fi system if you've got a building nearby that you can install a Wi-Fi gateway, but those are kind of your options for those remote sites. Question about, I can tell some of you guys are remote. Somebody's asking about satellite coverage. At this point, we do not have a satellite option for our stations. We are actually looking at documenting a satellite that will work with our RX 3000 stations. So that's something that's we've actually tested it and we've got it working now. We just don't really have the documentation in place for configuring that. So yeah, if you're at a remote site and you've got the funding to justify a satellite system, give us a call. We might be able to help get you started on that, depending upon your timing. Let's see. Let's see. Some of these questions I'm gonna have to follow up. Like there was this question on software recommendation for flow conversion if you've got our standalone loggers. I don't have that handy, but I can follow up on that. Yeah, here's a question about protecting the water level sensors from flow debris and holding them in place. Yeah, I didn't really talk too much about the mounting of the sensors in streams and rivers. And obviously, if you're doing a flume or a weir, you can mount a stilling well in the flume or on the weir. A lot of times you'll see, and I think some of these pictures that I showed you, they've got the corrugated metal stilling wells next to the stream or river. A lot of your USGS sites and a lot of your irrigation management sites have those stilling wells that are adjacent to your streams. If you have access to one of those, that's a great way to a great place to install your water level sensor for monitoring water level at your site. If your site doesn't have one of those, you can install a stilling well down the side of the stream because pressure-based sensor, that's one of the advantages of them. They don't have to be in a vertical stilling well. You can have a stilling well that goes down the side of the stream with your cable, and just make sure that it's well mounted into the side of the stream so it doesn't get swept away by the flow or the debris. And make sure that the end of that stilling well is down in the part of the water that will always be submerged, so you'll always be able to monitor water level in that stream. But that's something to keep in mind. Here's a great recommendation. The USBR's Water Measurement Manual is a great resource for flow conversion. I in fact referred to that in some of my studies. Maybe we'll share that as part of our follow-up, because I think that is that's very true. So thanks for sending that over, Josh. Let's see what other questions we have here. So I'm just kind of reading, that's why I'm pausing here. Some of these are a little bit question about reading out the Bluetooth loggers that we offer deployed in a manhole. And that's a pretty common question, is you want to have a water level logger down in the manhole. Is that Bluetooth going to go through the steel cover for the manhole? And the Bluetooth is not strong enough to go through a steel manhole cover. So in that case, you either have to pry the manhole cover off to get the wireless communication to go through it, or there are some like plastic. So they don't call them plastic. They have fancier names for it. Manhole covers, composite, I think is a better name for those, that can go over them. But to be honest, those are not that commonly available. But if you can get a composite manhole cover for your site, the Bluetooth will go through those as long as it's not too deep into the manhole. So that's something to keep in mind. Yeah, so here's a question on how many water level sensors can the MicroRX take. The MicroRX only has one water level sensor input, and that's built into it. If you want to connect two water level sensors, you can do that with our RX3000, which has two module slots, and each one of those can have a water level sensor module in it, so you can get two sensors into those. Here's a good question, is about changing geometries. Yeah, that's an issue if you're in a natural stream site and you're using a stage-discharge curve to calculate your flows. Is you do have to keep updating your stage-discharge curve for changes in the geometry of your site. So if debris is washing down into it, or one bank is washing out in your site, you may have to adjust that relationship between stage and discharge rates. So that's part of the maintenance of using that technique for doing your flow measurements. So it does get, it is a commitment to do that. And that's where it's important to have a tool, such as Aquarius, for example, to be able to do that maintenance, or the USGS tools for doing that maintenance. Let's see. Here's a question on how often do you need to clean the sensors? The pressure sensors, if it's a natural stream environment, they hold up pretty well. I'd recommend if there's any sort of sediment flowing through the stream, that you want to have a stilling well that uses like a slotted PVC type stilling well, which has basically it's razor slits in it that allow the water in but keep the silt out. Sometimes we even use landscape fabric in those stilling wells if there's really a lot of silt in the environment, and wrap the water level sensor in that to keep that silt from getting into the pressure sensor. But those are kind of the more extreme environments. In general, water pressure sensors, if it's reasonably clean water, they stay pretty clean. And let's see. Just going to see if I can catch a couple more questions. Sorry for my silence. Looks like I've gotten through most of the questions that I think are generally applicable. These have been great questions. Oh, here's a question about a submerged weir with downstream water level. Yeah, you'd need to have a couple of water level sensors if you've got a submerged weir. And yeah, to be honest, I haven't dealt much with the math for those. So I don't have a good answer on exactly what you'd need to do, but yeah, you definitely need to be monitoring water level at a couple points. So our software would not handle that case. So thanks for asking that. Okay, let me scroll down here. Oh, the question in follow-up, I was talking about wrapping the sensors, the water level sensors in that landscape material. In that case, you'd have a pipe with slotted PVC pipe. Then you'd have the sensor inside it, and you'd wrap the sensor in that landscape fabric. And that way you can, when you pull up the sensor, it comes up with a landscape fabric on it, and you can clean it off at that time or replace it. Yeah, here's just a question asking for clarification about stilling wells. And they're just basically asking, is it okay to have the stilling well mounted at an angle? And yes, absolutely. A stilling well can be mounted at an angle, because the water level sensor, if it's pressure based, it's monitoring the changes in water pressure, which is the water level above the sensor, the head above it, is the way it's often described. Now here's just a question specifically about the MicroRX. Can you read out the baro data to use it to calibrate other U20 data? That's a good question. Yeah, you can read out that barometric pressure data. Oh, and then you could import that barometric pressure data into the data assistant for the U20 loggers and use that to do your barometric correction. So yeah, absolutely, you can do that. Oh, here's the question about when might you need to use an external solar panel with a MicroRX. For the most part, the solar panel that's built into the MicroRX station is big enough to keep it powered year-round. But if you're in a more northern climate, you might need to use a external solar panel in the winter months, or you might need to slow down your cellular upload rate so that it's only uploading the data every hour. It's the cellular upload, which uses most of the battery power. So those are a couple things. Well, at this point, I think I'm going to just kind of wrap it up. I have a couple more slides to share with you. And just this one is just some of our contact information. And I suspect most of you are familiar with our website. It's a great resource for full product specifications and pricing. It's got other webinars like this one up there that you can download at any time. It's got tutorials, self-guided trainings, and of course, we've got live application specialists and technical support. As I mentioned, many of us are working from our home offices, but we're still working, and we're here to answer your questions. So feel free to give us a call. And at this point, I just want to say thanks for attending. Glad you're all able to join us today from your home offices, and so hopefully I was able to provide some good information for you that helps. And stay safe and stay in touch.